All right. Hi, everyone. This is Leetcode Weekly on this 510. Uh, mm, so, um, hours, right? Return. Okay. Ink hour one, uh, minute one, and then second one, inked hour two, minute two, that's two. Um, H1 is equal to string to inked. Start time, substring, 02, right? Yeah, okay. And then M1, STOI, start time, dot substring, starts from 1, 2, 3, 3, 2, and then S1, STOI, start time, um, start time dot substring, and then 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. Same thing with H2. Output H2 minus H1 times 3600 plus M2 minus M1. Actually, M1 plus equal to 60 times H1. M2 plus equal to 60 times H2. Um, S1 plus equal to 60 times M1. S2 plus equal to 60 times M2. Return S2 minus S1. All right, 25, 1504. Okay. And then total cost versus all elements. Okay. So modulo, right? Um, pay units of resources. You must process the elements of nums from left to right. Process the ith element, you need nums I resources. Um, I this URL by key. Minimum total cost. Num0, we have 3 units left. We have 1 unit. Uh, using costing 1. Oops, 2. So long answer. Right. Inked add 0. We'll just use longs. Okay. For inked x ink nums. You start off with k, right? Yeah. Long r is equal to k. Uh, inked need inked ops is equal to x minus r divided by k plus k minus 1. We need the ceiling of this. So we do this many operations. Ops is okay, k is 1. Uh, add to add plus ops minus 1. So answer plus equal to 2 times add plus minus 1 times ops divided by 2. Yeah. Answer divided by equal to mod and r. What does r equal now? R equal r plus ps times k times x. And then add plus equal to ops. Return answer. 3, 15, 0. Okay. Sign integer overflow. Then not take mod. Okay, wait. 2 times add plus ops minus 1 divided by mod. There we go. That was okay. We're doing okay. We're doing good. We're equal to exactly k paths 1. K paths. M, N, and K. Construct any M times N grid consisting only of dot and hashtag, where dot represents a free cell, hashtag represents an obstacle cell. Valid path a sequence of free cells such as starts at a top left cell, ends in a bottom right cell, moves only right or down. Exactly K valid paths. Okay. Two paths. Right, one, and then two. Okay. 1, 2, 3, 4. And no paths. Okay, so you can do this and then you do that's one path and then you add another one, so this becomes two paths. Yeah, if you have a over here, right? And then you add this one, you get add one extra. You add another one, you get one more extra. And you add this one, you get one more. Okay. So construct, right? You can go here. I feel like gotta go diagonal. I think diagonal's easier. I'm not sure. What about this one? A is smaller than B. Grid IB minus grid IA is less than or equal to limit. Okay. You may remove 0 or more columns, at least one column. The maximum number of columns that can remain. Uh, 250 over here. 10. It's 10. Okay. And K is only up to 4. Okay, so yeah, you can go ahead and make this swirly shape. 1, 2, and then one more. Uh, if K is 1, right? and we can your string grid M. Yeah, grid M. String N, and we'll do hashtags for entire 0, I smaller than n, I plus plus, g m minus 1 I is equal to dot. For j is 0, j smaller than m, j plus plus, g0 j is equal to dot, and then output for auto and passing g out return g. Yeah, we return g. Okay. K is 2. 1, 2. That doesn't always work though. So we can go here, right? We make the diagonal shape. You know what? We're just gonna make the diagonal shape first. So if I is equal to j, or I plus 1 is equal to j, grid ij is equal to dot. So this is 1. So this is one move. Um, return g in the end. So over here we have this diagonal shape, and then we have one more, right? So we can use this one. We can also use this one. This will give us 3, right? So over here, like this. If we use this one, we get 1 extra. If we use this one, we also get 1 extra. Right? If we use this one, it's also 1 extra. So 2. Um, if we use this one also, it's 1 extra. 2 extra. Right? 1, 2. Okay. Yes. M equals 1. This is one way. What's another way? Or okay, return this if m is equal to 3 and n is equal to 2. Return this. If it's 3, right? 1, 2, 3, 4. We already have 4. Okay, so we have 4 over here. It's 2 by 3, then 1, 2, 3. We have animal 3. Okay, so these are the invalid cases. Invalid cases. Now the valid cases. We already have these, and then we already have these, and then we add this one, right? And we add this one to make it 3. If we instead added this one, and we added this one, how much would that be? That would be 1, 2, 3. That would be 3. Okay. So if k is equal to 2, grid 0, 1, 0, 1 is used. 0, 2. Can we use 0, 2? Grid 1, 0. Else if k is equal to 3, we can try to make this shape. instead of dash 8, can we do something like this? Okay. So for here, 1, 2. So over here. Oh, if this is only if m is less than or equal to n. That's if it's not, then we have to swap it. If k is equal to 3, right? M is less than m. So if they're ones, we already used that. And if they're twos, m is always over here, like over here. So we can always use this spot, right? Always this spot. And then we can always use this spot also. Can we? I think we can. If it's 2 by 2, we already took care of the 2 by 2 case. Z02 is not. Okay. Also, if k is equal to 4, then we just make this shape and we'll be fine. So G10 is dot G02. Wait, no, it's Z G2. But if m is equal to 2, we can't do this. There's a lot of casework. I don't think I'm doing it correctly. I'll just make a separate case for m is equal to 2, I guess. Because otherwise this would always work. Um, okay. A is equal to n minus 1, n minus 2. A is greater than 0. No, greater than n minus 2 minus k minus 1. Okay, we'll just see if the m is less than or equal to n case. What happened over here? It's not return. So dot dot hashtag dot. No, this is incorrect. This is the case where m is equal to 2. Wait, our diagonal shape doesn't always work, does it? No, it doesn't. Okay. M is less than n. Into j is m. 2 onwards. G M minus 1J is equal to dot else for int. I is equal to n. I is less than m, I plus plus, g, I, m, n minus 1 is equal to dot. Okay. Hashtag hashtag what? And this doesn't work though, does it? If we get something else like 2 2, wait, 2 2, right? 2 2 and then a 2. If it's a 2, this works, right? If it's a 2 and a 3 and a something is 4, right? 2 um 2 3 5. Uh, actually, yeah, 2 3 4. 2 2 4 4. Yeah, 2 4 4. Then this would fail. So this adds 1, right? G20, G02, and G03. Right, if it's 4, it must be like this. Okay. Not really sure this works though, so I'm gonna stress test. 1 5 1 5 1. 1 5 1 fails. How does 1 5 1 fail? M is 1, N is 5, and K is 1. This pair is okay. Uh, we gotta add this parentheses. Okay. Okay, this works. 2 2 2. Okay. Something else, right? 2 4 4 4. Dot 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 dot. 1 2 3 4. Okay. And then oh, hold on. 5 2. Is this part wrong? I don't remember if it's car and then inked or no. Okay. So out of bounds, right? M is 5 and N is 2. K is 3. Over here, I have a 2. M is 5, N is 2. but only a few test cases missed, so we should be okay if I correct this. G 10 is a dot, and G20 is a dot. Right, this should be okay. M has to be at least 3. If M is 2 and N is 2, and K is greater than equal to 3, we already recorded this. God, okay. 824. Over here. Because it's 2, so it doesn't work like that. I think what we need is a special case for 2 or something. I don't know. Y okay minus minus. Grid 1j is equal to dot. Return G. Else if n is equal to 2, ain't I is equal to m minus 2, right? No, I starts from 1. Y okay minus minus. Just over here, j minus minus. G I0 is dot. And then I plus plus. Return G. Okay. Is this correct? Yes, it's correct. Is this correct? 1, 2. No, this is incorrect. A minus minus. Okay. So with MS2, we're gonna completely redo this. Wij is a dot. There we go. K dot. Okay. Feel what we get over here now. 2, 3, 4. Yeah, it should hopefully work. Yes, okay. Oh, that was not very good though. I got 2 wrong answers. Okay. I didn't like that problem. That was A lot of casework. Okay, so this problem now. Right, we just gotta remove columns until the limits work. And it's up to 250, so we can do n cubed. So I think what we can do here is we can keep track of the column that were removed. Can we do that? I don't know. Okay, but I'm thinking of DP right now. But it might also be DSU. Here, these two connected, these two connected. Or these two are connected. Also, we can do that. So any two columns, if they can be together, we set them as okay. Size m with 0.size. For into 0 is smaller than n. I plus plus. For into j is 0. J is I plus 1. J smaller than n. J plus plus. For every, okay. For into k is 0. K smaller than m. K plus plus. If ABS grid IK minus grid JK is greater than limit OK IJ is 0, OK JI is 0, and we can break. Okay, so this should be fine. Right, we find the pairs that are okay with each other. Now technically we just gotta find the maximum that such that all of its edges are connected with each other. So like there's n minus 1 edge, I think. How do we do that? Oh, it's supposed to be columns? The number of columns are okay with each other. So, right, for example, these two are okay with each other. Now if okay, this one, and then so these two would form their own set, and they'll be okay. I think given 80, given 80, then what JC makes it find the largest set of nodes set such that they all have edges with each other. I'm not sure how to word it. Um, oh, it's such that they are complete. Is it over here? Yeah. Doesn't use craft inside. Set they form complete. I don't think this is right, the right one. The one I'm going to find. So 250. So these are the ones okay with each other. The number of columns okay with each other. So given a graph, find the largest number of nodes such that they form a complete. Okay. Uh, is it in here? Okay, I think you can use this. N plus M log N plus M. This one is better, I think. Okay. And we can't update this, I think. We'll just change this just a 0, right? Okay. Complete components. So not graph node.size. Um, component. Now we can do vector ink. Those are the edges, right? So we need edges. Count the components and edges. Okay. Oops. Runtime error. Yeah, 3 over here. Um. Oh, if let's check if okay. 2, 2, and 1. Okay. Output 0. Limit is 6. Did I do something wrong again? What? Grid KI K0 I minus this greater than limit. I mean, what? Shouldn't the answer be 4? 7. Okay. Adjacent. Oh my god. Expected 5. Teacher, now we can use something, right? I and I plus 1. J is just I plus 1. Okay, okay is 0. Right, if okay, count plus plus, else answer equals max. Answer count, count is 1. Answer equals max answer count. Right, 1. Uh, count starts at 1. 2, 1. I miss 1, right? Okay, the relative order. Okay, so, hmm. So it's like a DP. If okay, dpj equal to max dpj dpi plus 1, uh, max element, all dp. 2, 2, 1, 2. I 5, 1, 2, 2. Okay. All right. Okay, so we're done. Yeah, this was not very good. Mostly because I got an insanely large amount of wrong answers. Um, my rank will probably still be okay, I guess. All right, so I'm gonna get on with solutions. Okay. So, for the first problem, you're given two times and you want to find the length in seconds between them. So what I did, right? First, I have hours, minutes, and seconds. I first find the hours, minutes, and seconds of each of the times using string to int. And then we can just change the hours to minutes, right? Minutes plus equal to 60 times hours. Because 1 hour is 60 minutes. So after we update our minutes, we can update our seconds. Right? Seconds is six there's 60 seconds in a minute, so s plus equal to 60 times m. And in the end, we can just output the difference into seconds because we just converted all of them into seconds, and now we can just subtract. So just implementation. For the second one, it's just some math, right? So yeah, for this one, um basically you iterate over all of the nums. You calculate how many operations you need, and then you add the amount to answer, and then you take a mod, of course. I'll go into these details later, but you find a number of operations, you add that amount, you add some amount to answer, and you can update your current remaining value, right? Your remaining units of resources, and then you update your add value. So for every indexing nums, right, the operations will be the ceiling of x minus r divided by k. Because you need this many to be able to get at least x, because you need to subtract from x. So first we find a number of operations. We do operations divided equal to mod. Oh, I never did add divided equal to mod, but it's fine. Operations says okay, operations divided by mod, and then for our answer, right? Currently we're adding add, so we're going to add all the way to add plus ops minus one. So using just a you remember make it just it's increasing by one, right? So we can just use a formula for this. So first one plus the last term is over here times the number of terms divided by two. So this is what we add to our answer. Answer take the mod of that, right? And then this is our remaining. The remaining turns into remaining plus OPS times K minus X. And then we add this OPS to our add, right? From now on, we're going to be adding this new add. And then we can take the mod of that. And in the end, we just return our answer. So again, just math and implementation for this one. Okay. For problem 3, my implementation's not really that good, but basically it's a bunch of casework. But basically I spent way too long on n equals 2 and on n and m equals 2, so I didn't do well on that part. But okay. So basically what I did, right, I have if you have the grid, all right, initially it's all filled with these values, right? And then I make it diagonal, right? Dot, 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 right? If there's any extra, I just make it go down like this. And then I notice, right? Add, um, if we say, let's do this. Yeah, okay. So if we add one here, so currently K, we have one path, right? If we add one here, we gain a path. If we add one here, we gain another path, right? But so we can get K equals 3 using that. But also if we add a point here, we add a point here, then we get k equals 4 in this case. So that's basically what I did. Special cases is m and n equals 2, where you have to separately account for them. But otherwise, you just split into 3 cases, k equals 2, k equals 3, and k equals 4. And then you just follow what I did over here, right? And you can update your grid accordingly and you can return it, right? If n is equal to 2, so for example, um, like this, right? Um, First of all, I should say the cases where it doesn't work, right? If any of them are 1 and k is not equal to 1, it's none, right? If they're equal to 2 and k is up 3 or 4, it's none. If it's 2 and 3 and k is equal to 4, it's none. So if n equals 2, basically in this case, you go like this, you make this path over here, and then while it's not possible, you just add 1. Because every time you add 1, k increases by 1. So you can just keep adding until you have enough paths. For m is equal to 2 is the exact same thing, right? So basically you first make a path like this, and then you can increasingly add paths, like you can increasingly add points over here until k is okay. Because every point you add, k will decrease by 1. So yeah, that's really what I did over here. There's the implementation details. I'm not gonna go through them, but yeah, it's just casework. This one. Okay. Problem 4, I didn't read the problem correctly at the beginning, so I didn't solve it correctly, but it's just a DP, okay. So basically what it means, right? You remove some columns, and then in the end, you find that the adjacent columns, the difference between every single value of them is less than or equal to limit. So that's the problem statement. So it's a DP, right? For every index from 1 to m, for every column from 1 to m, you check a previous column. And then you check if you can go from this previous column to this current column. So basically you check if all the absolute differences is less than or equal to limit, right? Because if it's less than or equal to limit, you can come from this previous column. Meaning you can delete all columns between these two. And then you'll between j and I will be adjacent, which is valid, right? So you just check if it's valid. And if it's valid, we can just update our dpi to max dpi dpj plus 1. Because it can come from the previous dpj, right? And dpj is the, I should say this, right? dpi is max number of columns less than or equal to I and including I, right? And then so dpi is just max dpi dpj plus 1 because we come from j, right? And there's j columns from the center to j. And then we can come from that, so we add a 1. We add this current I to it. And then in the end, we can just return the max element of d and of dp and we're done. Yeah, so this problem before. Um, if you saw that you only check the adjacent, I think this would be pretty easy dp. Yeah. Constraints allow you to go up to n to the cube, so it's fine. Okay, so those are my solutions. Um, my rank is probably gonna drop to 1,000 something, yeah, because AI is gonna solve it a lot. But I hope after cheaters are detected, I'll go up to uh under 1,000. I think I will lose rating from this round actually. But yeah, all right. So this is my contest. Um, yeah. So bye bye.